Hello, dear viewers. Good day to you all. You're welcome to today's class. So, today I want to discuss the pH scale in chemistry. However, our concern is the calculation aspect of the pH scale. So, the formulas which are important in solving calculations under the pH scale. So, we know that the pH scale ranges from 0 to 14. Okay, so at 7, which is the middle. So at the 7, when we have 7 here, we call it the neutral point. So here, this is neutral. What else? And any number between 0 to 7, that is any number which is less than 7 at this point here, we call it acid. And any number greater than 7, that is from number greater than 7 here, it is basic. We either call it base or we can call it alkaline. Okay, so this pH scale is under a topic in chemistry which is known as acid, bases, and salt. Okay, so for us to solve any calculation aspects under the pH scale, there are four important formulas we need to know, which I'll be stating today. So the first formula we need to know is that pH plus POH is equals to 14. Another formula we need to know is that pH is equals to negative log of base 10 of H plus. And the third formula we need to know is POH is equals to the negative log of base 10 of OH minus. And the fourth formula is H plus multiplied by OH minus is equal to 10 raised to the power of minus 14. So with these four formulas at the back of our hand, we can easily or we can solve any question brought to us under the pH scale. So kindly study the four formulas. So the H plus here is the hydrogen ion, while the OH minus here is the hydroxide ion. The question says calculate the pH of 0.005 mole per dm cube tetraoxosulfuric acid. So solving this, the first step we need to do is to write out the chemical formula for the compound that has been given, which is tetraoxosulfate 6. So the formula is H2SO4. So looking at this compound here, tetraoxosulfuric acid ionizes completely in solution. So this compound here, as you can see, this acid is dibasic. So as such, every mole of the acid we ionize to give 2 moles of hydrogen ions. So writing this chemically, so this is going to be, here is hydrogen, so this is going to be 2H plus. So this is the hydroxide plus, here we have SO4 2 minus. Okay, so from here we can solve further. Since it says we should calculate the pH of this compound, so what we need to do, so let's before then, let's bring out the four formulas I stated in the previous class. We have a formula which says that pH is equals to negative log of base 10 of hydrogen ion, and also we have POH is equals to negative log of base 10 of OH minus. We have another equation which says that pH plus POH is equals to 14, and H plus multiplied by OH minus gives us 10 to the power of minus 14. So from these four formulas, these four formulas will always guide us to know, depending on the type of nature of question given. So from here now, looking at this, the question has asked us to calculate the pH. So the pH of this acid. So for us to calculate pH, we can use this relation, the first equation, which says that pH is equal to negative log of base 10 of H plus. However, looking at this, we need to find the value for hydrogen ion. And then for us to get the value for the hydrogen ion, looking at the equation we have here, we can see that hydrogen ion here has 2. So here is going to be 2 times the concentration given of the concentration of the acid, which has been given as 0.0005. So multiplying 2 times 0.0005 on the calculator, this gives us a value of 1 times 10 to the power of minus 3. So this is the value for our hydrogen ion. But the question is not asking us to calculate the hydrogen ion, but we are asked to calculate the pH. And know that our pH is always between the range of what? From 0 to 14, as I mentioned in the previous class. So for us to calculate the pH now, we're going to use this relation here. So we're substituting the value of hydrogen ion we've got in, and this will give us the value for the pH. So from here, we have that the pH is equals to the negative log of 10 of the hydrogen ion, which we have gotten to be 1 times 10 to the power of minus 3. So punching our calculator, for us to get negative log of the value we have, which is 1 times 10 to the power of minus 3, the pH here gives us a value of 3. So the pH here is equals to 3 as the final answer. So the pH of 0.005 mole per dm cube of H2SO4 is 3. So viewers, in our next class, we shall solve as much examples as we can under the pH scale for further clarification. Okay, so thank you for watching. Stay tuned to my channel as we solve more examples. Bye for now.